Alright, what's up, guys? Welcome back to day 32 of intelligence maxing. So, today's stream probably gonna go over the project that I still haven't finished yet, and I haven't made too much progress. I think yesterday's class kind of helped me understand how to run the regression against the different factors now, and so I'm gonna try to keep working on that today. Hopefully get through the assignments and then also build some more intuition on how you can use these factors to determine the returns. Okay, so let's just go right into it then. Okay, so if we want to find the beta, right, I think what that is, it's kind of the normalized covariance of the returns on the high minus low book to market, and on also our market itself, so the market risk premium. Alright, in this assignment we have to look at the relationship between the Fama-French three factors, and then also how that kind of ties into the CAPM, the capital asset pricing model. Alright. So I did come up with these. Let's see. Right, so I did come up with a really low beta, which I feel like doesn't make any sense, because why is it 0.1? And I did that by running a regression using the high minus low book to market ratio as our independent variable, and then the market risk premium as the independent variable, and the high minus low as the book to market ratio as the dependent variable. So there's a really high alpha, and I'm wondering, what if we just kind of calculate the beta analytically? So to do that, I think we could just find the covariance of the two returns, and then we scale that by the variance of the market returns. So I'm going to try to do that first. Okay, so it actually seems like So maybe I might not want to use the cumulative returns actually. Let me just try using the scaled returns first. Okay, so I still have the same beta 0.1. So maybe there's low correlation with the markets and the high minus low. So that means they're rather independent, and there is kind of no alpha. So this is a really high alpha, so let's change this to the scaled returns instead. Okay, so now we have a negative beta actually. I feel like this means I feel like this has a more, what do you call it, economic meaning behind it, because when you think about high book to market versus low book to market, these are value stocks versus growth stocks, and whenever the market is doing really well, meaning I guess you could say there's a really high excess return, so market minus risk free, then you would expect growth stocks to outperform value stocks. But now we have a negative beta, so there's kind of this negative correlation between the market and our high minus low book to market portfolio. And let's see, in the periods, this is the periods of 1993 and beyond. And there's a few things that happened since 1993, right? You have the internet bubble. So a lot of these big high-tech growth stocks kind of were bubbling up in the early 2000s, and then that came crashing down. And then you also have a financial crisis in 2008. And I think the data itself ends in 2018, so this doesn't take into account of COVID and also kind of this big interest rate inflation scare that we had in the past 2 years. So I feel like in theory these numbers make a little bit more sense. I know the last time I ran this regression I had an alpha of like 27, so there's definitely no way that's possible. I think this definitely makes more economic intuition. I think this definitely makes more economic sense. I'm trying to think too. I might kind of restructure this problem where we have a regression run on the expected market risk premium, and then maybe we alternate with the betas. Right. So Okay, let's do this first. So let's go back to what I was trying to think about in the first part, right? We have ours. So we want to just calculate it analytically. Markets, ref, HML. Okay, so we have our market risk premium. All right, then let's do the covariance. Let's see, what is this going to give us? Okay. So these have a very, very low covariance, meaning that they're probably independent of each other. Okay, and then we could divide this by, oops, covariance matrix. So we want to get the covariance between the two, and then we'll divide that by the variance of market risk premium. Okay. So we get 0.1537. Yep, so that's the exact same actually. That is the exact same as the beta that was just spit out by the stats model package. So I think we might be on the right track here. So I think the analytical solution is going to be the covariance of oh wait, do we square it though? That's actually something I'm not entirely sure. Do we square the variance? Oh, no. No, we don't. Because sigma represents standard deviation, and I think it's the standard deviation squared. So we just square the standard deviation, which is equal to the variance. All right. So this question is, how would you test the hypothesis that long value short growth outperforms the market? Have the returns on the strategy waned since the attention How do we test this strategy? So what type of statistical test would we want here, right? What is an F test again? I'm gonna ChatGPT this. The variances of two population groups. Okay, I'm not too sure if this is exactly what we need here. So one idea I do have is if we use the idea of capital asset pricing model, we can kind of compare the two alphas together, right? But I think from the regressions that we ran, the alphas are the exact same. The exact same meaning that they're pretty much zero. It's only really the betas that have changed. So if the beta is now negative, or maybe there's another way we could test it. We could compare the returns before 1993 and after 1993. I'm trying to think. And then maybe use the sample mean from the returns of before 1993. And that could be our null hypothesis. The alternative hypothesis is that it's higher. I have to think about this one. I'm going to skip this for now. Let's move on to the next question. Okay, so let me pull up. He has the lecture notes somewhere here. What? Oh my god. Okay. My monitor's spazzing out. UMD. Come on, please. Please log in, please. Okay, nice. I'm in. I'm in the mainframe. Oh, and my computer just froze. Great. Great. Yep. And oh, there we go. There we go. And it's frozen again. Okay. All right. So what's lecture notes? Lecture notes 6. Okay, and then we want page 19. All right. I'm just gonna download this real quick. I'll bring this over here. Okay. Okay, so page 19 does not have the picture or the figure that he's talking about. So that's not good. I'm assuming that it's somewhere here though. So he also has this. So he has the expected return divided by t. Okay. So I'm assuming it's something like this, where each dot represents the average excess returns. Okay. Alright, so I'm thinking then maybe these against returns predicted by the CAPM. Okay, I think I'm starting to understand a little bit more how to think about this. Let's go over to this part. So in part 4, we're trying to replicate what is called the value anomaly, and double sorts. I think this could be. Oh, wait. Yeah, I think this has to be somewhat close to this idea where you have high book to markets, like related average, realized average excess return. So the value stocks have low betas, so lower risk, but have higher returns, which is contradictory with growth stocks that have high betas but lower returns. So this is what we want to replicate in part 4 of the homework. Okay. Next column. So there's a few things I need to do before I actually find the sample averages. Right now, I think I just have to convert the index to a datetime format and then actually use the data between the periods in which we need to. Okay. So I wrote some code for that earlier. Let me try to just copy and paste it.
喂，你跟我说下个月开始，你要去电影是什么时候开始？你跟我说一下嘛。
对。
3月8号。
Okay, now.
下午再处理一下，然后2跟4我去找，对啊，然后2跟4我去找那个。
Period.
然后这个是我朋友啊，一个是什么朋友？他有这个时间嘛？所以我在想要不要问他。
Okay, nice. So I've converted the actual. Wait, yeah, so I converted the index to datetime now. I think now I actually have to select the time periods. So it's gonna be 1963 January, and then it'll go until December 25th. December 2015. Okay, nice. So we have the returns here. Alright, now we have to find these sample averages. So I think what we could do is we could just call a simple Python function, and that'll just give us sample average. So these are a sample average of monthly returns.
思就是说，他这个做完以后，他就可以啊。那你意思是不是说那个
Okay, wait, let me plot
就
the betas to
就算你是白天去上班，那
average monthly
需要
returns. Okay, so those are the average monthly returns, and then we want to, I guess, run the regression for all of these. So we want to estimate betas. All right. So def find beta. Just create a function for that. Okay, so to estimate the beta, we can run the regression or we could just do it analytically. I think I'll just try both. So could do market. I think the easiest way to do this is we can compute the covariance, I think, by just taking the sum of the product of the errors.
或许那个其实平安现在
The sum of the product of the difference from an observed value and also the mean of, and also the sample mean, and then we divide that by n.
早上我们大概就是那10点大概出去。
I think maybe it'll just be easier to use a Python function to do that computation for us. So I'm thinking maybe we could just we can add these two things into a data frame, and then we'll just call the covariance function. And then I think that should be easy as that. Okay, let's think about this then. So terms df is equal to data frame market returns portfolio returns. Okay, so we have this data frame, and then do covariance matrix. Is equal to returns of the covariance. Okay, so we have the covariance matrix, and then once we do that, we could just take the covariance. So return covariance matrix block. So for, let's see, for column in EM, if you have period 1, columns. Okay, so I'm thinking that we could go through all of the columns. Okay, so these are all of the columns. We can just iterate through that, and then for each column, we'll just estimate the beta itself. So let's try that then. I think the right. I think an important thing we need to do though is I need to merge the two data frames together. So I need to merge the data frame, or at least the data frame with the market risk premium. So I could take the scaled data frame. Okay, let's see if this works. I could maybe do DF scaled, and then we'll merge on the index, because both indexes should be the same. They should just be the date. Okay, so let's see if that causes anything to crash. Okay, so it did. Shit. Wait, actually, let me see. Oh, nice. Okay, we do have the market risk free. So we can iterate through the columns. The problem now is that we also have this market risk free column, and we don't want to compute the beta for that. Actually, in that case, the beta should be 1, right? Because we can just do it. Fuck it. All right. So we estimate beta. Sample beta. Sample betas that append sample beta. Alright, we have an invalid index error. Okay, why is that? Is it because, wait, let me, where's mine? Oh. No, this should be good. Okay, let's see why this doesn't work actually. So I'm confused as to why there's a 1 in here. Like a month variable. Oh, okay, I think I might have found out why actually. Yeah, I think I just missed the closing brace, so that fucked everything up. Okay. Now I think we could plot the returns against the betas. Alright. So let's plot plt.subplot x.plots. I think we probably want to plot these dots. So I think we could just specify that in the function call. So in our x-axis, we want these sample betas. Y-axis should be the average monthly returns. And then on the Y, okay, I think we need to specify it to be a circle. And then color, let's do, we could just do blue for default. Alright. Getting an error, not too sure why. Why is sample betas not? Okay, it seems like this thing is just not iterating through anything at all. Print column. So it is iterating. Oh, right, because every single time. Okay. The reason why is because every single time I was going through the next iteration, the list just resets itself. Okay. Rookie mistake. Alright, there we go. Now we have okay, So this is not what I would expect this to look like. Um, hmm. Realized average excess return. Hmm. So I feel like we have similar excess returns here. 0.05. Actually, maybe not.
So I'm using FFmpeg to extract all frames.
But I think we can maybe set the Y limits to be a bit bigger. So I'm forgetting the actual, what you have to pass in here. Oh, bottom. Bottom we could do maybe 0.05, 0.004 top, 0.015. Then we can set the X limit to maybe 0.8, set the 0.15. Alright, that kinda did not do anything, really. Okay, shit. Alright. There we go. That looks a little bit better. I'm trying to think. We should probably label each of these two. I forgot how I did that in the earlier section.
Oh boy, you win. Nothing else. I started July 2020. Oh my.
Okay,
Okay.
column
See you
and
later.
columns. Okay, oh man, what was the Python function, I think? I think it was enumerate, it'll give you the value in the index. Okay, so I think we could do that here to get the value and the index itself. Because we want the text to be the column name, and then we want to get the beta, which is the index, from the sample betas list. And then we want to get the returns. I think we could just use the column name. So too many values to unpack. Oh, because I never really called the enumerate. Okay. Alright, let's see. Let's see if this works. Okay, I think it did work a little bit. Let's see if the columns actually show up now. Nice. Fuck. Nothing's actually showing up on the graph though, so what's going on here? Okay, I think the offset might be a little bit too big. Right, because my offset is 0.005, but that's how much our Y label is. Okay, so I think maybe if we add an extra 0, let's see if that changes anything. Please, please, please. No, it does not. All right. You think, oh, okay. So there's this other problem where I have my X and Y axis flipped. So how should I just just delete this and then just paste this over.
Going from the other hyperview talks meetings.
Alright, cross my fingers. Let's go! Okay.
That was really good.
Showed up. High 10.
Then I think next week there are some more things that I can understand more.
Hmm. You know, just based off first glance looking at this, I'm having a hard time believing that the highest book to market value have the highest beta as well. It kind of goes against the economic intuition of having a value stock versus a growth stock. Okay, this makes sense. The market return has a beta of 1, so it's just going to be perfectly correlated with itself. Yeah, this is kind of the most interesting part where...
Did you ever go to that place when it was not at the truck?
No. Did it used to be not a truck?
No.
the lowest book to market has...
The same place?
Yeah. I'm surprised we didn't take you there for lunch. Where did we take you for lunch?
Burlington. And then
And what you would do for breakfast?
breakfast at the hotel, big hotel.
That's a mistake.
So, I heard like all the family parents are going to want to do for lunch. So far, right?
Yeah, this is
No,
the biggest anomaly
for-
here. How
for
come
some,
the
I mean, what do we do
lowest...
for breakfast?
the lowest book to market ratio has a lower beta compared to the highest book to market ratios.
Which is
Does it have to do with maybe
what
the...
you're actually going to do if you come here. And
This is a pretty extensive
getting in the mindset of
period,
what you're going to
actually.
be doing.
So I'm surprised that we see that. What if we just did that for all the data, though?
Then we actually have a shadow thing, which is insane considering how good it is.
Okay, so if we delete this, then I'm just gonna see what it looks like with all the data instead of...
I'm trying to recruit a student who's master student admin.
Right, our shit just disappeared.
She could potentially do it.
So I think if it disappeared, that means it has too high of a beta, or maybe too high of
And then
a...
after she's after the visitor, she's gonna help.
An average return.
Could
Could be both.
No.
Because I feel like otherwise there will be a very big difference. coming from Manhattan to the College Park.
Yeah, College Park is that.
Yeah.
But like, you can't really place them downtown for a first visit, because like, it's gonna be too stressful to figure out how to go from College Park to downtown on the morning hour.
Okay, let me see
But
what
it's
the
totally doable.
BM10, BM1.
You can put them on the hotel that we, I think we put you as well, or one of
Yes,
them.
yeah.
Which is when you're buying. Same thing we did from Indiana. Put them in the hotel there, go and grab coffee and walk around in the morning. It's like, we do that,
Yeah.
right? Like that's what I do. I put up over here, coffee. And then drive in, have the meetings, have the talk, and then go back down.
Okay, this is even making me
I don't
more
think it's
confused
gonna
because
make The people.
now
who
I'm
are
not
purchasing
entirely
the
sure what
Indiana
these labels mean. Low, low 10.
are the ones that actually got hired. Maybe, I think. You still have a good time. Don't think about it.
Okay, let's also kind of expand the limits here. We're testing the limits, so let's see what happens. Okay. So let's change this to 17. Does that do anything? Alright. No, that does not. Alright, 1.3.
So are you going to all the talks so far?
Not all of them, but I've been to quite a few. I mean, I think only my case has been to more.
Okay, so it seems like higher betas then.
The two quantum, the two PL, the 1PL, and I did one more.
Hey, there we go. Alright.
The computation by.
There
Oh,
we
okay.
go.
The two quantum and then the first one was the business stuff? Someone in the
Yeah, so this is actually the exact opposite of what this graph looks like.
Who was maybe Thursday? Yeah, like how consider online tools help with your workplace productivity stuff like Zoom.
I don't think I remember that. I didn't look at that. Some is like that. It seems like that. Not even close.
And that one just seemed like really what a business tool for working, not really for computer science. Yeah, he was talking about during Zoom meetings, how often do people multitask? Multitask basically means you got distracted, you check emails.
Yeah, this graph is actually confusing me now.
Oh.
Yes.
I mean,
How the hell does this have such high of a beta?
wow.
Let me also add the labels too to make this a bit more clear. X stats.
We're doing a lot of this fun.
Oh, and then the last part of that talk was can you use ChatGPT to automatically write reviews for research paper submissions? So that's like this researchers who are really like more
Okay, so here's what we have.
That's gonna make them even less privileged.
Yes, I know. But all these
I'm
topics
curious.
are like something I'll never think of for even use or ECE, but maybe, yeah, business school, they care about like organizational productivity or whatever.
But like, I disagree with that premise here. No. And you should take it to write reviews. Like, fine. I can sort of agree that some people will try to might as well know if it works or doesn't. But like if your premise is that it's for the point of turning around, helping underrepresented people, turning around maybe more quickly, just like that. The only people who will get actual feedback are the ones that are already in like UMD and CMU or whatever. And everybody else will get cookie cutter reviews, it doesn't matter, so
No, because the how
what the hell?
things were used.
Yeah.
All right, I feel like I'm going crazy, so let's take a look at the analytical solution for the betas.
Under review in nature.
Seems insane to me.
Wow.
Great, it's not even in this lecture. Okay.
I mean, it's
All right, let me also, you know what?
Exactly.
That's just
I
wrong.
know.
I'm going to run a regression here, just using the.
Every time there's a review, just like keeps it moving and gets less good at it.
All right, I'm gonna try running a regression just using stats model instead of trying to actually calculate everything myself. Okay, so let's try that. Okay, so that crashes. Let's do. What did I import it as? SM. Okay. So I think. Let's use our independent variable as the market returns, and then our dependent variable as the portfolio returns. Oh, I think we also have to add a constant.
I mean, at that point, I can imagine if an adversary generated a complete gibberish that are created just so that they can maximize whatever.
SM dot
it does under the hood.
add constant. Okay.
Like you can just change the content you check in slider. You can change it from a bad review to a good review.
Yeah.
Anyways, I saw the vote, this one got pretty low votes.
Yes.
It was like, what?
Okay.
Why are you even studying these?
I think if you do results dot summary, let's see. We're getting some serious errors here. Okay, yeah, I think first of all I'm not returning anything. So I think let's just try to run through everything, and then we don't have to worry about creating the graph yet. I just want to see what the output is for the regression.
Yeah, I think that crazy how about fancy dinner. Tom Wilson is hosting .IPN. They're gonna have a fancy dinner.
So play
I just
results.
stopped because I saw the email when they vote. And it's probably already 40 votes.
Check.
No, then I emailed him, yeah, I don't know whether they're gonna change the resolution.
Okay, so the low has surprisingly close
Which one did they do? They done?
betas.
No, the one up north from.
7 reasons?
Rooster and Owl?
Yeah, Rooster and Owl is okay.
He's the only, oh, okay, then I don't feel bad.
Okay, so I'm not going crazy. Even the regressions themselves from stats models outputting
Worth going on someone else's time.
the market risk premium, the beta's higher.
But obviously because. Yeah, there's no way I can reply to you such a immediately.
Yeah. I mean, it's like underrated tasting menu, if I remember correctly, but there was. I think it was on the faculty interview.
This is so confusing. Okay.
Places are exactly what I tried. Except the ones I really wanted, like.
Yeah, now that you talk about it, yeah, it does just look like American.
Some interviews we went to Supra, which is awesome. And for something was at Focus, Amazonian, which is also amazing.
Is Maiden good?
I I've never been.
Okay.
I want to go, but like I haven't had the chance.
Fish looks good.
Okay, let me check. Alright. This is truly, truly an anomaly. I have no idea. Okay. Maybe we could then look at the.
Yeah,
Maybe we can construct a confidence interval
Good luck.
for. We can maybe try creating a confidence interval for the excess returns, although I kind of forgot how to do that, so I might have to look it up. The error bars are optional, but I recommend doing so. Okay. We also have to redo the analysis of the earlier period. What? How does the kappa work in the earlier sample? Hmm. I feel like I am going crazy. Ah. Okay, I think I'm going to come back to this. I'm going to think about this question a little bit. So we can go to question 2 then.
Yeah.
Alright, we have the covariance. So we want to draw the efficient frontier with 8 risky assets alone without short selling, and 2 with short selling. Efficient frontier with 8 risky assets.
Let me know when you take a look at the homework on the weekend. Let me know when you take a look at the homework on the weekend. I'll probably message you. Sean. See if he has some.
Yeah.
He might come in clutch too.
Which ones did you do? What did you
So,
look
I mean, part 1A is easy. There's 2 parts. B is probably easy too. I just haven't done stuff like that. It's just like some you have to do some like.
Okay.
at? I could probably solve all the recurrences.
Yeah, I did that. I think that's. I got to that because I knew that was gonna be.
The easy one, or the straight
But we can.
forward
But I
one?
think you should do it too, so we can.
Yeah, true.
Four. I had not figured out yet, but I have some ideas. I might have to ask Arvind or Mike. And then number two.
Okay, so I think for this of finding the efficient frontier for the n asset case,
Yeah.
So it's
we're
like
gonna have to use some type of optimization problem. And then I'm just gonna use kind of the SciPy optimizer. I forgot how to set the bounds for SciPy optimizer, so I'm just gonna look it up. Nice. Let me also see if this is still streaming. Nice, still is. Okay.
The sourcing actually has a
Like
lot.
basically the fourth problem. Fourth problem. The fourth problem was about like remember the vertex cover stuff that we were doing.
Yeah.
The recurrence we wrote for that.
Mm-hmm.
Basically he wants us to show how we can improve that.
Yeah.
So like for k less than equals to 3, he wants us to show that it's less than equals to just all number and an m.
Mm-hmm.
So but then like okay if you have n vertices and if you have k equals 3.
Okay, so
you're
I
just trying to
think
find
what
the
we need to
same
do then
vertices
is just
that
have a
maximize
tuple
coverage.
that has a lower bound and an upper bound.
And
Alright.
Which is like n to the k.
Bound is equal to 0,
I've gone in depth enough.
1,
So I have to
and then we have all bounds is equal to number of securities times bound. I wonder if we could just multiply a tuple with the scalar and just get that many amounts of tuples. Let's see. I haven't gotten error yet, so maybe that's promising. Alright, yeah, so now I got an error. It's saying that the int object is not iterable, so why am I getting an integer instead of a tuple? I see. For some reason, this is combining my bound or my tuples together into one. I don't want that to happen. Okay, I'm still having the same problem actually. How to, let's see, Python, how to actually, What if I change this into a list? Is this gonna give me the same idea? Let's see. Yeah, it does. Okay. I feel like there's a way to do this though. How to get tuple n times. Okay, so there is, but it's just a different syntax, it seems like. Alright. So we have to, for some reason, do this. I'm not fully sure why. There we go. X dot sum. So these are all ones, which is good. Okay. Now let's- okay, so the weights add up to 1, which is good. Now we have to plot them. Hmm. So we have our portfolio weights now, and then we need, I think, the variance or the standard deviation of portfolio, then also the expected return. So with that, I think what we need then is okay, so we have our covariance matrix, and we also have the vector of returns. We could just take the dot product. Okay, so returns is equal to, oh, let me first create a vector of portfolio weights. P dot array. Solution of X. Okay, so once we have our portfolio weights, we could say the mean returns equal to portfolio weights at what is it? Expected returns. Variance return for weights at. So we need to transpose, and then we take the covariance matrix. Covariance matrix for weights. Oh shoot. Alright, so how do I actually plot this then? just do display. Oh, plt.show maybe? Let's see. Oh, still nothing. Great. How to show the same X twice. Okay, so maybe I shouldn't have copied this over to a different section. Okay, nice. We do have a okay. This is promising. This is promising. Let's see. I think it's not super smooth though. It looks kind of like a stick figure. A badly drawn stick figure. I'm not entirely sure why it isn't as smooth here. Okay, it's still the same, kind of. I wonder if we make the bounds a little bit bigger, if this kind of smooths out a little bit. I'm not 100% sure, but it's worth a shot. So we could try that. X dot set. Slim. Do. For 2.0. Okay. Alright, and then we could take the y limits and oh shit. Oh shit. But yeah, what happened? 0, 1. This looks so wrong. This looks so crusty. Oh my god. I don't know how I feel about this. Goddamn. Even if let's say I push this up to 1,000, right? I feel like at this point it's probably, or what if I have less? So what if I do 50? $10? $40, $50, $60. Alright. Fuck it, I'll take it as it is. So we have this. Okay, so with short selling, without short selling, in our constrained optimization problem, I think with the short selling, okay, so without short selling, then all of the weights have to be positive. But if we do allow short selling, then all of the weights don't have to be positive. So we can have negative weights, and this will kind of extend the possible returns of our portfolio for higher standard deviations. Now, okay, so I feel like this code I wrote is kind of messy right now. There's a lot of parts to it, and it kind of smacked everything together. So first I'm gonna just define a function for everything I wrote. I think this will kind of declutter a little bit. Def construct efficient frontier. So we need the number of securities. We need the expected returns covariance matrix. Okay, and then I think that's good. And then also the constraint. Okay. Hmm. Okay, now that I've kind of smushed everything together, I think that's I think this is probably gonna be a bit more clean. Inputs slash parameters for expected returns. Okay, so weights dot sum minus 1. think that does that. I feel like that is a possible constraint because if you are 200% levered long, you need to be also maybe 100% short on something to compensate. Or maybe it can just be 200. Alright, so let's see if constraints is equal to, I think we do no short cell. Strings equal to short cell. So we can just remove the bounds. Python. Target returns, I think num securities, so be industry, lane industries. Okay, so we have the length of the industries, and then what else do we need? Expected returns, covariance matrix, and the constraint. Okay. So expected returns, and then standard covariance matrix. We also have no short cell. We need one for short cell, one for no short cell. Num securities is not defined. Oh, okay, maybe we can add an offset. Let's see. Return offset is equal to man, computer just froze again. Okay. Okay. So we have a return offset of, let's say, probably do 0.5. Yeah, 0.1, 0.5.
In case the MC2 sort of affiliation wasn't part of the official like offer letter, but it was something that talked about.
Limit. So 0, 2. Zero, 3, -1, 2. Okay. Turn limits 1, 0. Okay, so I want to kind of grab the first, the lower bound and the upper bound, and then do the same. Oh, so I think I actually have this switched up. The y limit should be the return limit, and then I think the x limit should be the standard deviation limit. Okay, so hopefully this will make the graph. Oh shit. All right. Well. Oh, okay. I just forgot to change the variable names.
Not too complicated so that we won't get lost.
Yeah. But once you figure out how these are going to
I feel like I'm actually doing this like to
Okay, so it seems like oh shit. It seems like I'm getting capped out somehow.
Yes, that's the one I like too, actually. And there's also this pork belly dish that
Hoping this will fix some stuff. Oh man. Okay, maybe 1,000's too many iterations. Yeah, I think it's causing my computer crash. Fuck. My computer is done for. It's completely frozen now. If you're still watching on the stream and it's working, let me know. But if not, then yeah. Oh, okay. Alright, it's back. So maybe 500 iterations is probably better. Okay, I think I want to zoom in a little bit. Turn limit. Let's do maybe 1.5, 2.
yesterday from New York City.
-0.3. Okay. So let's see if this works then.
Oh,
Alright, nice. We're getting somewhere. Although I think I feel like maybe my returns are still too high. So let's bring this down to 1. Okay, it's better. And I still feel like maybe 500 iterations is too much. I think 200 is probably a bit better. Because there's like a... Oh, it still freezes actually, with 200. So we do have kind of the possible portfolios that you can make with the basket of stocks. Now it's a question of when you add a risk-free asset, how does your Fisher Frontier look like? And so what is our risk-free rate? Right, so risk-free rate is 1%. And then in order to find the tangent portfolio, I think we need to maximize the Sharpe ratio. So the Sharpe ratio is just the expected excess return of your portfolio on top of the risk-free rate. And then we normalize that by the standard deviation of returns. I think then... if we can short sell the risky asset, then our line can kind of go off into let's say uncharted territory that doesn't even show up in our graph. So it just kind of keeps on going. I think maybe then is this going to be... I feel like we're going to have to create another maximization or minimization problem. This is hard. Okay, let me think about this. Alright, so our objective function then is going to be the Sharpe ratio. So that's what we want to maximize. Okay. Let me create this function first. Sharpe ratio. And then in order to minimize it, we could just flip the sign, so we'll take the negative of the Sharpe ratio. Alright. Let me think. We have the mean returns. So expected return. And then we have standard deviation. Portfolio. We have risk-free rate. So I'm trying to remember, right? If we try to maximize the Sharpe ratio, what changes? Is it the expected return or the standard deviation? Maybe the weights of the portfolio themselves? I think it's both the expected return and the standard deviation. Because we need to find the point tangent to the curve. Oh man, my calculus stuff is kind of fleeing me. I forgot how to do this. Okay. Gotta go use the bathroom. I'll be back in a sec. Let me see if this is still going on. If the stream is still going on. Okay, it is. Nice. Also, oh, one view. Let's go. We got one view on the stream. Okay. Thank you for the like and for the view. I appreciate it. Okay, I will be back in a sec. I'm back. So I'm kind of stumped here, right? I kind of know where the direction I need to go to. I just don't know how to actually get there. So, I wonder if there's a way to do this problem where I kind of put a constraint on the possible values that you could use, and kind of like a list of expected returns, standard deviations that we can choose from. And then we'll just pick the highest. We'll just pick the standard deviations and the expected returns that give us the highest Sharpe ratio. So I think if we do something like that, I'm not entirely sure if SciPy supports that. We could take a look. Man, yeah, this is pretty complicated. Target return.
That's a balance when you get to customers.
Yeah, yeah.
So, okay, let's try this. I wonder if there's a way that we could. Hmm. Ah, man, yeah, this is hard.
वो तेरे को आइडिया आइडिया क्या
How to find the maximum of a function given specific inputs. Python. Okay, I guess that's true actually. We could just brute force this. I didn't think about it. Let's see what happens actually. Okay. So we're given a set of standard deviations, and then we're also given a set of expected returns. We can loop through, and I think those are the same size too. So we can loop through the combined portfolio of expected returns. And then we just straight up compute the Sharpe ratio that way. And then we can find, I think there's an argmax function, we can find the index of the highest Sharpe ratio, and then use that to get the the combination of expected return and standard deviation. Okay. So let's do that then. Minus risk-free rates. Good thing I don't think we're actually graded on efficiency, so this can be as slow as possible, I think. Okay, let's do this. All right, we have 4 index in range, length of combined portfolio. Okay, we have 2 things. So let me label this before I forget. So brute force method to find Sharpe ratio. Return is equal to standard to turn portfolio. Okay. Then now we can sharp ratio is equal portfolio is equal to sharp ratio. Then we pass in expected return portfolio. Then standard deviation return portfolio. And then we also pass in the risk-free rates of 0.01. Okay. Alright, so now that we have that, what we could do, I believe, is sharp ratios is equal to a list. Sharp ratios dot append sharp ratio port. Okay. I feel like there's an argmax function, right? Argmax Python. Max sharp index is equal to mp dot array sharp ratios dot argmax. mp dot argmax. Yeah, we actually just might be able to do this. And then shoot. Max sharp ratio is equal to Alright, so now that we have that, we could just max sharp index. Okay. Get that, and then we want this to be a circle. So let's see. Let's see if this works. We should see some type of... Okay, this is on the actual... Yeah, I believe that's on. All right, let me change this to a different color because it's kind of confusing having all the same color dots. But the red dot should be the tangent portfolio. And oh my god, let's go. It's on our graph, which means that it is a possible thing. It's possible. Could be onto something here. We could be onto something here. Okay. So in that case, I think when I come back from class, I'll probably finish this problem up and then just... So I have to do this for 8 risky assets and then 30 risky assets. Okay. Yeah, this homework is so hard. Oh my god. But I'll finish this up later. Yeah, so I'll see you guys in the next stream. Thanks for watching. See ya.